We are now going to start learning the completing the square method. Now, solving equations using the completing the square form, solving quadratic equations using completing the square, and the ability to convert a quadratic equation into the completing the square is extremely handy throughout AS level and throughout the A2 level. So that's why we are going to explain you and make you learn this phenomena, this method at this point onwards, and completing the square will be explained to you across two different videos. This video will emphasize on how to add a number to make a quadratic expression a perfect square. Now, what do I mean by that? We are going to practice in adding a constant to x square and x term in such a way and identifying the perfect constant to make the remaining expression into the perfect square. For example, expressions like x square minus 4x. Now, this expression does not have a constant added to it, but we need to learn how to add a constant to this expression, this remainder expression, to make it into a, a perfect square of a bracket. Now, what do I mean by perfect squares? What do I mean by constant? As I go ahead with this example, with this working, things are going to become apparent to you as to what I mean with different things. So I'm gonna solve this example in different steps, and that's gonna make things apparent to you. The step number one for this: divide the coefficient of x by 2. Now over here we have x square minus 4x. Now what is the coefficient of x? We need to ignore the sign for step 1. I'm just going to write it over here. Ignore the sign of the coefficient. And that's what you need to do as well. You need to ignore the sign. Okay, so the coefficient of x is 4. So we take 4 out. And then what we do is we simply divide it by 2. And then we get a 2. Okay, and that's it for step 1. We transition on to step number 2. Now in step number 2, we need to put a square bracket around our answer for step number 1. Now let me just write it. Put a square bracket around your answer for step 1. Now our answer for step 1 was 2. So what we're going to do is we're going to apply a bracket to it, and then we're going to put a square to it. And that's it for our step 2. We proceed to step number 3, where we're going to add the result of our step 2. Add the result of step 2 to the original expression. Now our original expression was what? It was x square minus 4x. And our result to step 2 was 2 inside a square bracket. Now we just need to add this to this. So we're going to write the original expression x square minus 4x, and then we're going to add this to this over here, plus 2 squared. And that is it for step number 3. We proceed to step 4. In step 4, Since our result of step 3, what was our result for step 3? Our result for step 3 was x square minus 4x plus 2 squared. Step 3, since it was step 3 is similar to the form a square minus 2ab plus b square. See, a square minus 2ab plus b square, and x square minus 4x can be written as minus 2 times x times 2 plus 2 square. So this and this are extremely identical. This is a, we can call this a over here, there's an a over here. This is b, 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 and there's a 2 over here, and there's a 2 over here. Minus, plus, minus, plus. Extremely identical. And we know that a square minus 2ab plus b square, sorry, this was a b square. We know that a square minus 2ab plus b square was an expansion of the form a minus b square. Similarly, we can say that x square minus 2 into x into 2 plus 2 square was an expansion of the, since this was our a, this was our in place of b, we're gonna write, instead of a, we're gonna write x how we were writing it over here. Instead of b, we're gonna write 2 how we were writing over there. We're gonna write x minus 2 whole thing square. So we're just comparing this identity with ours. So now we converted our result of step 3 into this form, x minus 2 the whole thing squared. So what was the number that we needed to add? We previously, our original expression was x square minus 4x, which we converted to x minus 2 square. And what did we need to add a special thing in the process? We needed to add a plus 2 whole thing square, and plus 2 whole thing square was a plus 4. So plus 4 is the number. By number we mean the constant that we needed to add. We needed to add to make our expression into a perfect square. Now we are going to look at another similar example. For another example, we have x square plus 2x. We're going to follow the same step-by-step process. Step number 1, the coefficient of x, which is 2, we're going to divide that by 2 and we get a 1. And in step number 2, we apply the square bracket on the answer for step 1. We've done that. Then step 3, we need to add our result for step 2 to our original expression. Original expression was x square plus 2x. Our result for step 2 was bracket 1 square. We've done that. In step number 4, now since this time our result is similar to the form, it's not similar to the form a square minus 2ab plus b square, but it's rather similar to the form a square plus 2ab plus b square. See how we can write x, square, and then we can, instead of 2x, we can write 2 times 1 times x, and then we already have a 1 square. So you see a, and this is in place of a, A, this is in place of A. Sorry, this is in place of A. And this is B and B over here. So we can say this is in place of B and this is in place of B. We have a 2 over here, 2 over here, plus over here, plus over here, plus over here, plus over here. So we have it in this form. Hence, since we know that a square plus 2ab plus b square is an extension or expansion of the form a plus b square, we know that x square plus 2 bracket 1 bracket x plus 1 square is an extension of x plus 1 square. Since x was in place of b, a, and 1 was in place of b, it's x plus 1 whole thing squared. Now our original expression was x square plus 2x, which we made it into an x plus 1, the whole thing square. And in the process, the thing that we were adding specially was the the plus 1 squared. That means we were adding a plus 1. That means 1 was the thing that we were supposed to add to this expression to make it into a perfect square. Now, let's try questions that have a coefficient of other than 1 for x squared and for the expressions that we just did earlier in this video, and then try to perform the completing the square for them as well. Let's try to attach a constant to those expressions as well in order to make them a perfect square. For example, 2x square minus 4x. Now this is again an expression with the term x square and with the term x. Now if for in this regard, the x square does not have a coefficient of 1 but rather a 2. So there is a different way to convert these sort of questions into perfect square. Performing completing the square of such questions is a bit different than what we did earlier. So the step 1 is an additional step that needs to be added, which is that take the coefficient of x square out as common. So the coefficient of x square is 2. So we need to take out 2 common from both of them. And we're going to try to take out 2 common from both of them, even if this term is not being divided by 2. We'll show you further ahead in different examples how that can be done. But for this, we can simply take out 2 as common. And we're only going to take out the 2 as common. We're not going to take out x's as common, even though both of them have an x in common. We're only going to take out the constant as common. So we take away 2 and we're left with x square minus 2x on the inside. Now we're going to do step number 2. On step number 2, we need to focus on the inside of the bracket and then divide the coefficient of x by 2. So the bracket that we got in step number 1. That is what we mean by bracket over here. So in step number 1 we got 2 bracket x square plus 2x. So we're going to ignore this 2 on the outside for a while, and we're only going to focus on whatever is inside in the bracket. So x square plus 2x is what we're going to be focusing on. So the coefficient of x is 2, and we're going to divide that 2 by 2, and then we're going to get a 1. And that's it for step number 2. In step 3, we need to square the result of step 2 and put a bracket around it. So we're going to do that. The result of our step 2 was 1. So we're going to write 1 and put a square bracket on it. In step number 4, we're going to add the result of step 3 inside the bracket. So we started off with 2 bracket x square plus 2x, and our result for step 3 was 1 square, and we're going to add it inside the bracket. So it's going to be x square plus 2x plus 1 square. That's how we're going to do it, and that is it for step number 4. We're going to transition on to step number 5, which is we observe an identity inside the bracket. Now inside the bracket, now in step 4, we finalize 2 bracket x square plus 2x plus 1 square. 2 bracket x square plus 2x plus 1 squared, and this seems similar to a square plus 2ab plus b square, because this can be written like this: x square plus 2 into x into 1 plus 1 square. So this is a, this is a, this is b, this is b, and 2 over here plus plus. So when this can be written as a plus b square, we can write this as x plus 1 square as well. But that means that we can, instead of 2 bracket x square plus 2x plus 1 square, instead of this we can write x plus 1 squared, and we're gonna copy 2 as it is. So 2 bracket x plus 1 whole thing squared. And then after that, that was our step number 5. And after that, we're gonna do step number 6, which is expand the result of step 5. So we had 2 bracket x plus 1 whole thing squared. When we expand it, we apply the identity x plus 1, apply the square to it, we get x squared plus 2x plus 1. We expand it using 2, we get 2x squared plus 4x plus 1. 2x squared plus 4x plus 2. Beg your pardon. Then for step number 7, we compare the result of step 6 with the expression with the original expression in the question. So our original expression was 2x squared plus 4x, and our step 6 expression was 2x squared plus 4x plus 2. Now what is the additional thing that we're adding? We're adding this 2. We were adding this 2 to make it into a completing the square form like this. So our answer is 2. 2 is the additional number that we needed to add to make this into this form.